All right, so we have an oxygen ion. We have its mass, we have its velocity. It's moving perpendicular to a magnetic field, and it makes a circular arc because it's moving in a magnetic field, right? 4 electrons are missing from the ion. So what is the radius of the arc? Well, we know we've got our equation R equals mv over qb for the radius of curvature of charged particle moving perpendicular to a magnetic field, right? So it's going to go in this circle. And what are the pieces we have? Well, we know the mass, 2.66 times 10 to the minus 26 kilograms. We know the velocity, 4.27 times 10 to the 6 meters per second. We know the magnetic field, 1.38 Tesla. And we know the charge because we know we're missing 3 electrons. So the 4 electrons, pardon me. So the charge is 4 times 1.6 times 10 to the minus 19th coulombs. Right? Each electron missing, an electron has a charge of minus 1.6 times 10 to the minus 19 coulombs. Since we're missing 4 of them, we have 4 times the opposite of that charge. All right, so we know the charges, we know everything in this equation, we just have to put it together. R is mass 2.66 times 10 to the minus 26 kilograms times velocity 4.27 times 10 to the 6th meters per second divided by charge 4 times 1.6 times 10 to the minus 19th coulombs pardon me, times the magnetic field, 1.38 Tesla. All right. Now we just need to put all of that together. Pop over to Excel. So we have our charge, our mass, 2.66 e minus 26, right? And we have our velocity, 4.27 times 10 to the 6th. We have our charge, which is 4 times 1.6 times 10 to the minus 19th. And we have our magnetic field. And now we're going to calculate the radius of curvature, which is going to be the mass times the velocity divided by the charge times the magnetic field. And the answer is supposed to be in centimeters, so we're just going to multiply this by 100 to get from meters to centimeters, 12.86 centimeters. And there you have it for problem 4.